Hello and welcome to my channel. So today I want to carry out explanations to calculating areas and perimeters of plane shapes. The shape we'll be putting into consideration is a circle. Now a circle has a normal area which all of us knows. But first, what is a circle? So a circle is a plane shape that is bounded by a curved line called the circumference, right? And we know that it has a center, and then the distance from the center to any part of the circumference is called its radius, right? So if we know that, we also recall that the area of a circle is given by pi r square, and its perimeter is given by 2 pi r. Now these conditions are applied to now if you have a condition where the diameter of the circle is what is given instead of the radius, that means maybe you have something like this, and then they say the distance through the center from one portion of the circumference to the other is the diameter, and that's the value that is given. Then we can take the area to be pi d square over 4, and the perimeter to be pi d. Now this is true because our diameter is twice the radius. You can see that the diameter can have one radius here and one radius here, so the combination of these two radius make this one diameter, right? So if you make r the subject of the formula here, we're going to be having diameter divided by 2. So if this value is substituted into this, d will be squared and the 2 will be squared, so you have over 4. If this d over 2 is substituted into this, d will cancel out this and becomes d over 2. Then this 2 will cancel this, so you are left with pi d. Okay, so if that record has been set straight, let's also consider other situations. Now there are other cases that this very circle can be shaded. Now the circle can be shaded into 3 parts. It can be shaded into half of its size, 1/4 of its size, or 3/4 of its size, right? So half of its size is like 2/4. So let's say we divide the circle into 2 equal halves, and any of the portion is shaded. If this is the case, we can also look for the area, but let's not forget that since this is the diameter, we have 2 radius, right? So if we are looking for area of this shaded portion, since this circle is divided into 2, we will have it that it is 2 over 4, because if we recall, a circle, if you want to divide it, a circle can be divided into 4 equal parts, right? Now this is the first quadrant, second quadrant, third quadrant, and fourth quadrant, so everything will be over 4. So if this circle is divided into 2 halves, it will be 2 over 4. If this circle is shaded only half of its size, it will be 2 over 4. If only one portion is shaded, then it will be 1 over 4. But if 3 portions are shaded, it will be 3 over 4. So since this portion we only have 2 of each shaded, we have 2 over 4 of the area, so the area still remains pi r square, right? So this can be broken into 1 over 2 pi r square. Now if we prefer to use pi d, then the area will still be 1 over 2 pi d square all over what? 4. Now, what about the perimeter? Now, the perimeter has to be the distance from this portion. So if I call this A, let's say I call this portion A and this portion B, right? Let's say I call one portion of the circle A and the second portion B. So if I want to look for the perimeter of this shaded portion, so it will take the distance from A to B and these two radius. So how do we get that? Remember, this is divided into two halves, so it will be 2/4. Then what is the perimeter of the formula for the perimeter of a circle? Still remains 2 pi r, right? Then with the two radius, so you have plus 2r. If you prefer to use the pi d, well, it's still the same. So this cancel, this will be 1/2. You'll be having pi d plus, since 2r represent the d, it will be now plus d. Anyone you prefer to use, your answer will still give you the same value. Okay, let's go further to other examples of portions of a circle that can be shaded. Now, let's say we have another circle, right? And it is designed this way. The only one portion of it is shaded, right? We'll recall that this is also radius. The distance from the center to any part of the circumference represents a radius. So now, since only one portion is shaded, recall what I explained here. So I'll be having the area to be 1/4 pi r squared, right? If I want to use d, that is the diameter, it will still be 1/4 pi d square over 4. Then what about the perimeter? If I want to work with the perimeter will still be 1/4. Now, what is the formula for calculating perimeter? We have 2 pi r but plus 2r, right? So it also applies that if we want to use diameter to be 1/4 pi d plus d. Anyone that is easy for you to use, you can just use it, right? But don't forget that before you use diameter, you should always consider the radius. So if it is diameter that is given, you can divide the diameter by 2 to have radius. But if it is radius that is given and you want to use diameter, then you can multiply the radius by 2 to have your diameter. Okay, so another condition that I want to observe here is when a portion of a circle is shaded this way. Here, don't forget that this is still our radius and the whole of this portion is shaded, meaning 3 quadrants are shaded. So if this is the case, then the area is going to be 3/4 pi r square. If you are using diameter, it will be 3/4 pi d square over 4. Then if you want to look for the perimeter, it will be 3/4 2 pi r then plus 2r, or 3/4 pi d plus d. Okay, this is where we're going to wrap up for this. But let's not forget that the conditions that you can have is when you have a plane circle. You have a plane circle as this. You have a circle divided into two halves as this. You have a circle that only one portion is shaded, And the last but not the least, you have a circle where 3 portions are shaded. Alright, I'll see you in the next video where I will explain each of these conditions and will solve some problems on it. Bye for now.